So as you all know, developmental dyslexia is one of the major learning difficulties with 8 to 12% prevalence. And it stays with children, and it's really difficult for children, because when you realize that most of the school learning is based on reading and writing, it became clear why dyslexia may imply so many social and personal costs. So it's really important to fully understand the nature of these difficulties and find effective therapeutic programs optimally adjusted to the individual difficulties. And dyslexia is known as specific reading difficulties, but also is associated very often with spelling deficits. I guess that all of you have started to read these words on the slides automatically, but actually reading is very challenging and very demanding. It's a very complex cognitive process. Children need few years of training to learn how to read. For example, to read word aloud, children see letters, needs to recognize letters and correspond that letter with the more abstract form, graphics, and then with phonics. And in case of spelling, for example, in writing to dictation, children hears the word, needs to distinguish all phonemes in the word, then associate them with graphics, and then write it down as a string of letters. That's why phoneme to grapheme conversion is necessary for reading and for spelling, and this ability to recognize phonemes in the word. So the understanding that there are different sounds of words that you can manipulate, it's called phonological awareness. And we test phonological awareness with very simple tasks. For example, we ask a child if two words rhyme or not, if they start with the same sound or not. And problems with phonological skills. Phonological deficit is also a very powerful developmental dyslexia predictor, because based on assessment of phonological skills, we can predict if a student will be a good reader or a bad reader, even at the beginning of the reading education. When we look at the neuroimaging studies, we constantly find underactivation in left hemisphere language regions in children with spelling and reading deficits compared to the control groups in different phonological tasks performed in the scanner. These are underactivations in ventral temporal regions, temporal parietal cortex, temporal and frontal regions, and also we found in previous studies we constantly found overactivations in again temporal parietal and frontal regions, and they are interpreted as a kind of compensatory mechanism. So the suboptimal way of processing works. But those studied dyslexic groups suffered from both reading and spelling deficits. So that's why it's very difficult to say which abnormalities in brain structure as well as in brain function are associated with spelling deficit or with reading deficit. So our goal was to separate those influences of spelling and reading deficits, but we have also a second, more practical reason. Because in Poland we have a large group of children only with specific spelling impairment, not with reading impairment. So they are typical readers, but they suffer because of the spelling deficit. And we want to find neural and behavioral reasons for a specific spelling deficit in Polish orthography. And to do that, we collected data from a large group of children, over 170. We tested them with battery of normalized tests for dyslexia diagnosis, and children performed 3 phonological tasks in scanner, and I will tell about it in a second. And we were able to distinguish 4 groups based on a standardized criteria described in the Statute of Normal Test for Dyslexia Diagnosis in Poland. So we had control groups without spelling or reading deficits, group with reading and spelling deficit, and groups with isolated spelling deficit and reading deficit. So thanks to that, we could use two-way ANOVA as our test to see main reading deficit effects by comparing groups with and without reading deficits, and also main spelling deficit effects by comparing groups with and without spelling deficits. And when we look at those groups, you can see that they are fairly distributed, fairly separated. Those blue dots are controls, so you can see that their spelling and reading skills are the best. And also the red dots are the group with spelling and reading deficits. When you look at the reading deficit group, the green dots, you can see that their spelling is at the control group level, but the reading is worse. And when you look at the spelling deficit group, the purple dots, they are reading not as good maybe as controls, but their spelling is worse. Okay, so in our lab, in Debska Institute of Experimental Biology, we have a mock scanner where we prepare children for the fMRI tasks, because we are aware that this kind of procedure, this kind of experiment might be difficult for children, and we want to make everything, the atmosphere as most comfortable as we can. And the whole story behind the phonological tasks. So the whole story behind phonological tasks is about the secret language of dragons. I hope that you all seen dragons there. So in the first task, child needs to assess if 2 pseudo words taught by dragons are the same or different. In the second task, if they rhyme or not. And in the third, most complicated task, most orthographic task, children needed to assess if 2 pseudo words with the same sound or not. And we decided to use pseudo words because we're interested only in phonological processing, and also those are auditory tasks. So there was no written words or letter on the screen. And when we look at the behavioral results, here you can see the accuracy level for all groups. The accuracy was pretty high, around 90%. But we found, in all 3 tasks, we found main spelling defect. So groups with spelling deficit were significantly worse than others. And it's actually in line with previous literature, especially in the German sample, which is also transparent orthography. And you can tell that if you're poor spellers, you will have problems with basic phonological tasks. But I don't want to leave you with the idea that only poor spellers will have phonological problems, because before this, in scanner tasks, we also had more difficult phonemic deletion tasks. And here we found, as well as spelling and reading effects. So it means that also readers, of course, have phonological problems, but maybe on a different level. And spellers will have problems on more basic level, whereas poor readers on more complicated phonological tasks. And when we look at the results from brain imaging, in the first task, when children needed to assess if the pseudo words are the same or different, we found We found underactivations for poor readers, also mainly reading deficit effects in the temporal cortex that in literature is associated with bond to graphing correspondence. And for poor spellers, we found overactivation in right inferior frontal gyrus. In the second rhyming task, we found only as a main reading deficit effect, we found overactivation in right middle temporal gyrus, and no main spelling effects, which might be understandable because this rhyming task is not that much orthographic like two other tasks. And in the third most demanding orthographically task, first phoneme matching, where children need to assess if two pseudo words have the same first sound. We also found, again, in poor readers, overactivation of right middle temporal gyrus, and for pulse spellers, underactivation of left ventral occipitotemporal region, which is pretty interesting because it's a region that, based on the previous literature, is in the same place as visual glotophonaria. And here in our tasks, we don't have words, or we don't have any visual stimuli, only arbitrary pseudo words. So it means that it was enough to see coactivation of the orthographic representation, right? Even though children don't have to process words. So to sum it up, we found as a main reading deficit effect, so for poor readers, we found underactivations of left parietal cortex that we interpret as a problem with graphing to phoneme correspondence, and for poor spellers, underactivation of ventral occipitotemporal region, that is well-known region for orthographic processing, and also we found different, we might interpret it as a compensatory areas in the right hemisphere, inferior frontal for poor spellers, and middle temporal for poor readers. So to conclude, apart from this neuroimaging results, we also wanted to stress that we found that spelling is more vulnerable to the phonological deficit than reading. And we are also interested in this kind of analysis in different orthographies because our study is limited only to the Polish orthography, which is relatively transparent. So it's interesting if we can find the same results in more opaque orthographies, for example, like English.
Great, thank you. We have a few minutes for questions, if anyone has any questions. Go ahead. Oh, we'll just put the mic to you.
Thank you very much for the nice presentation. I was wondering about the results you showed of the three fMRI tasks, where you were showing reading-related results and spelling-related results. I was wondering how the three different deficit groups were split in the result pattern. So I was wondering if there were differences between the children with the reading and spelling deficit compared to the children with the isolated spelling deficit.
So we found, because we used Tuyanova as our basic statistics for behavior results and for brain results, here we found main spelling effect for all three tasks. So, and here you can see the distribution of the results in all groups. But I haven't compared all groups separately. So.
Yeah, good. That might be. Thank you.
Any further questions? Go ahead. Oh, we just put a mic there, it's fine.
I was wondering if you had any views about the direction of causation, of whether there are brain activation differences which cause reading and spelling deficits, or whether the reading and spelling deficits cause different strategies which cause brain differences.
Yeah. Well, this is a very important and very difficult question. Well, in my opinion, what we observe is, reading difficulties and spelling difficulties, but of course, behind that, we have impairments in many cognitive skills, like phonological processing. And there are studies that pre-readers have different their brain function in a different way during phonological processing tasks than pre-readers without, for example, familial dyslexia risk. So I guess obviously it's an interaction of, for example, familial risk for dyslexia and then later educational context. So I think it's more like an interaction and not causation in one way or the other.
Oh, sorry, we just went out.
Yeah, thanks again for the talk. So you were recording effects in both hemispheres of the brain, right? So you were running a phonological task, and there were effects in the left hemisphere and the right hemisphere. And usually, if you go into like meta-analyses of phonological processing, so rather typically you would expect effects, left hemispheric effects. And now you come up with these right hemispheric effects. And I was wondering what a possible explanation might be. So is there some, bilateral crosstalk going on, or how would you try to explain?
Well, I couldn't change the slides, unfortunately, but okay, answering your questions. So it is, so I was not surprised that I saw right hemisphere underactivations for poor readers or for spellers, overactivations, because it is, I think it's common in literature when you compare dyslexic groups to the control groups, it's really often, really often you can find overactivations in dyslexic in right hemisphere regions, especially in frontal and parietal, compared to the control group. And it is interpreted as a compensatory or the suboptimal way of processing with the right hemisphere, because if you have problems with left hemisphere processing, you will use probably part of right hemisphere, but
okay. The right frontal overactivation, was that in spellers?
for poor spellers.
But not for poor readers?
Yeah, but also right middle temporal gyrus for poor readers in two tasks, in rhyming and initial phoneme matching. So that is also interesting that it was in two different tasks.
Okay, thank you.
Any more questions? Okay, well, thank you very much for opening that.